Okay, let's just dive right into this. We're about to pull back the curtain on something we use every single day, but, almost never actually think about. The incredibly powerful, hidden logic that's running our language. And the key to unlocking it all is a concept you probably never heard of, but you use it constantly.
I mean, we do it effortlessly, right? We form sentences, we express all these complex ideas, and we understand each other without consciously thinking about all the grammar or the logical structures underneath. It just works.
But just look at this for a second. On the left, a sentence that's a total breeze to understand. All students read a book. Simple enough. Now look at the one on the right. Different students answered different questions. It feels just as simple, but as we're about to see, the logical engine required to process that second sentence is in a completely different league. And that's the puzzle we're digging into today.
So to really understand the puzzle, we first need to look at the basic toolkit we're working with. Let's start with language's simple rules and this concept called monadic quantifiers.
So most of our simple sentences run on words like all, some, or most. These are called monadic quantifiers, and the key part of that word is monadic, which really just means one. They grab onto one group at a time. So in all students, the word all just has to worry about the group of students. That's it. It's a nice, simple, step-by-step process.
But what happens when that simple, step-by-step logic just isn't enough? Let's take a look at where the rules start to bend, and then break.
Take a look at this classic example. Now, with our simple monadic tools, we might try to process most men first, and then, okay, let's process most women. But that doesn't really work, does it? The meaning isn't about two separate groups, it's all about the complex relationship between them. That admire each other part links them together in a way our simple logic just can't handle.
And this, right here, perfectly illustrates the core problem. Sentences like this are called irreducible, or, for the linguists in the audience, non-Phrygian. You just can't untangle them into a simple sequence. The meaning of most men is deeply dependent on the meaning of most women, and the other way around. They have to be understood together as a single complex unit.
So, if our basic toolkit is broken, we clearly need something more powerful. It's time to introduce the hero of our story.
How do our brains process these incredibly complex ideas so effortlessly? Well, the answer lies in a totally different kind of logical tool.
Meet the Polyadic Quantifier. Now, let's just break down the name. Poly means many. So, unlike our one-at-a-time monadic tools, a Polyadic Quantifier is built to grab onto multiple groups, multiple variables, all at once. It's literally designed to handle relationships.
Okay, theory is great and all, but let's see how this powerful new tool actually gets used out in the wild.
And it turns out this isn't some obscure, rare thing. This powerful logic is woven all throughout our language. We see it in branching structures, in sentences with words like each other, and even in simple comparisons. They are seriously everywhere once you know what to look for.
Let's start with maybe the most famous type, branching quantifiers. This is where the simple, left-to-right reading of a sentence completely fails us, and we need a tool that can kind of branch out to handle multiple ideas at the same time.
And we're back to our tricky sentence. A branching quantifier solves this puzzle by creating two independent branches, one for most men and one for most women. And then it evaluates that admire each other relationship between them simultaneously. It's not a straight line, it's more like a web.
Okay, next up, another really common case, reciprocal constructions. The name kind of gives it away. These are all about back and forth, mutual relationships. And as we've already learned, those are often irreducible.
This sentence is all about correspondence. It's not just any old student and any old question. A Polyadic quantifier handles this by linking a specific student to a specific question and another student to another question, maintaining that unique pairing. It's a breathtakingly complex operation that we perform without a second thought.
So we know these tools exist, and we've seen them in action. But for those of you who are curious, let's take a quick peek under the hood at the rules that actually govern them.
When linguists and logicians study these quantifiers, they tend to focus on a few key properties. We're going to touch on two of the most important ones, reducibility and composition.
First up is reducibility. This is really just a simple question. Can we break this complex quantifier down into a series of simpler monadic ones? If the answer is yes, we call it reducible. But if the answer is no, like in our examples, it's irreducible. It's a single, powerful, non-Phrygian unit that has to be analyzed all on its own terms.
And then there's composition. Now think of this like linguistic Legos. We can actually build these powerful tools by combining simpler ones. So for example, by combining a most quantifier with another most quantifier, you don't just get two separate ideas. You can create a single, more complex tool designed specifically to handle the relationship between those two mosts.
Okay, I know this has been a pretty deep dive into some abstract stuff. So what's the big takeaway here? Why is understanding any of this important?
Here's the bottom line. Our language has different gears. For simple ideas, we use simple, one-at-a-time logic. But to express the complex, interconnected, and relational ideas that make us human, we need a much more powerful engine. Polyadic quantifiers are that engine. They're the invisible logic that lets us talk about relationships and comparisons and reciprocity.
You know, the most amazing part of all of this is that this incredibly sophisticated logical machinery just runs silently in the background of our minds every time we speak. We are all master logicians, and we don't even know it.
It makes you wonder, doesn't it, if this level of complexity is hiding behind a simple sentence, what other invisible structures are secretly shaping the way we think and communicate every single day?